Quantitative analysis is a race against time. You either process market data instantaneously or fall behind the curve. But historically, that process collapses under the sheer weight of the raw material. The friction point is extraction. Analysts spend hours manually pulling specific, buried data points out of dense, multi-hundred-page PDF 10Ks and quarterly corporate reports. Dexter solves this friction by entirely removing the traditional interface. Instead of staring at a terminal or parsing a PDF, a user can query the system natively through a WhatsApp gateway, dropping the barrier to entry down to a simple mobile text. Dexter is an open-source, autonomous financial research agent. It operates as an independent worker, capable of taking a high-level directive and executing the granular steps required to fulfill it. It does not rely on predictive text to guess an answer. It actively searches the web and computes live market data, structuring a bespoke research plan for every unique query. When human parsing becomes the bottleneck, shifting from manual extraction to agentic automation is the only mathematically viable way to scale quantitative research. The engine driving this autonomy is built on a specific, modern runtime architecture, Bun and TypeScript. This stack provides the high-performance execution speed required for real-time market queries, while TypeScript enforces strict type safety to prevent logic errors when handling complex, multi-layered financial structures. Once deployed, Dexter relies on its primary operational mechanic, dynamic task decomposition. It takes a monolithic human question and fractures it into small, executable programmatic steps. But executing steps is only half the process. Dexter's secondary mechanic is stateful self-validation. It uses an LLM-as-judge loop to evaluate its own work, checking the data it retrieved against the logic of the original question. This creates an architectural tension. True autonomy requires the agent to iterate until it finds the correct answer, but unconstrained iteration introduces severe cost and operational risks. Deploying this agent means developers must thread a very tight needle. They have to enable frictionless, deep research while wrapping the system in strict programmatic guardrails. Tracing a WhatsApp query, the packet hits the Bun backend, initializing a local directory. Specifically, it creates a Scratchpad folder with a JSON-L log file, capturing the init prompt, and expands placeholder slots for tool result and thinking, preparing an action ledger. Parsing multi-layered financial variables requires a perfect memory of every step taken. If the system loses track of whether it has already pulled Q3 earnings, the entire subsequent calculation is compromised. By logging every thought and action to a local Scratchpad, the system achieves strict software observability. The agent's internal logic becomes entirely transparent to the developer. State secured, the query moves into the core agent logic hub, transitioning to active execution. The agent begins task planning, actively breaking the prompt apart into discrete structured research steps, creating parallel pathways. To gather hard quantitative data, the agent runs a tool selection protocol, bypassing internal memory. As we see here, one subtask is routed directly to the Financial Datasets API. This specific integration extracts exact figures from corporate balance sheets. Simultaneously, a second subtask routes to the EXA API, retrieving real-time web context and news data. Once the external tools fire, this raw, multi-source data travels back down the branches, converging at the central agent node for processing. By dynamically routing tasks to live APIs in parallel, Dexter ensures its calculations are based entirely on current market realities, completely eliminating the risk of hallucinating numbers from outdated training sets. Gathering the data is only the first phase. The agent must now inspect the raw tool result inputs it just received. This is the validation engine, governed by an LLM-as-judge protocol. The model actively cross-references the newly acquired API data against the strict parameters of the init query. Integrating with LangSmith maintains visibility, tracking internal scoring. If data satisfies the prompt, success triggers, compiling blocks into a confident answer. But if failure is met, identifying missing data, it flashes yellow, halts output, generates a thinking block, and routes back. With every subsequent pass, the local Scratchpad updates, logging exactly why the agent rejected, the previous data, and what it intends to look for next. Single-shot LLM generation is critically insufficient for quantitative finance. To achieve actual accuracy, a stateful, iterative self-correction engine is mandatory. That self-correcting logic makes the system highly accurate. It also creates its most dangerous operational vulnerability. The iteration loop is designed to run until it succeeds. If the agent encounters a query it cannot resolve, or a data source that continually returns formatting errors, that validation loop easily devolves into an infinite recursive cycle. The financial consequence of this is immediate. An unconstrained agent caught in a logic loop will rapidly and continuously ping its connected services, burning through expensive credits across OpenAI, Anthropic, and Exasearch APIs in a matter of minutes. To prevent massive API bills, developers must configure Dexter's built-in loop detection protocols. The system has to monitor its own repetition, slamming the brakes the moment it recognizes it is caught in a recursive pattern. As a secondary defense, the architecture requires hard step limits. By capping the maximum number of iterations allowed per query, the system ensures that even a silent failure eventually times out. For engineers, this dictates a strict deployment reality. Thorough testing in a localized sandbox environment is an absolute prerequisite before connecting the agent to production data or live API keys. Autonomous agents like Dexter offer a massive leap in research scale and speed. But that power is only usable if developers architect strict, fail-safe constraints around the very autonomy that makes the system valuable.